Hello, I'm Ricardo Rivera. In AP Physics C Mechanics, the traditional method of adding two-dimensional vectors is a slow process involving conversions from polar to Cartesian coordinates, and then back to polar. This presentation will show you how to use imaginary numbers, an inbuilt function on your TI-84 calculator, to take some shortcuts. This does not require any actual knowledge of imaginary numbers. This shortcut isn't always useful. A rule of thumb is to only use this method if you're dealing with polar vectors, which are vectors consisting of a magnitude and a direction, such as the example you see here, 50 meters at 37 degrees east of north. Using imaginary numbers sidesteps the use of all trigonometric functions to convert to Cartesian coordinates, which can be difficult for many users. Cartesian coordinates, as of the form 40 meters north and 30 meters east, are easy to convert by hand and won't really benefit from using this shortcut. This method will require some setup on your calculator to work properly. You'll only need to perform this setup step once, or if you ever reset your calculator, because the options here are fairly unintrusive and won't interfere with any normal calculations. Your calculator will need to be in radian mode, even if you're doing math in degrees. It might already be in radian mode, such as if you're taking AP Calculus as well as AP Physics. The number type setting, the lower one you see here, needs to be set to a plus bi to allow the imaginary number calculations to work. However, this won't interfere with any calculations you do using real numbers only. To type a polar vector into your calculator using imaginary numbers, use this format here, me to the I pi over 180 times theta. M is the magnitude of your polar vector, with any units of course removed. In the example you see here, it's the 30 on the right. Theta is the angle, and in particular, it's the angle in degrees above the horizontal. For instance, northeast is 45 degrees north of east, and therefore 45 above the horizontal. If somehow you have an input in radians, which is exceptionally rare in AP Calculus, you do not need the pi over 180 conversion factor. If you're unfamiliar with using I in calculations, it's the imaginary unit, and all you need to know is that it is accessible by a second, which is kind of the shift button, and then the decimal point. If you're inputting Cartesian vectors, despite the fact that it might not save you too much time, use this format, a plus bi. A is your distance along the horizontal axis, and b is your distance along the vertical axis. Note that in our example here, the 15 meters south is marked negative 15i, because north is the positive direction. You have to ensure that those line up where east and north are positive and south and west are negative. The bulk of the shortcut's time saves occur here, where you're actually adding all the vectors together. As you can see, you simply type them all in one line, with plus signs between them, to add them together, even if they're in different formats or there are more than two vectors. As you can see here, it works fine to add together two Cartesian vectors and one polar vectors. There's no need to use trigonometric functions on the polar vector to convert it to Cartesian coordinates. The calculator handles all that automatically, which is much faster than doing it by hand. The only thing to watch out for is any negative signs, but parentheses can help with that. As you saw on the last slide, the outputs of this function are in Cartesian coordinates. That is, they're of the form a plus bi. This is easily converted to xy coordinates, or, say, a direction north and a direction west. However, you might need your output in the form of a polar vector instead. To convert from the complex Cartesian a plus bi output to a polar vector, you can use these two steps. First, use it as the input of the absolute value function to determine the magnitude. The absolute value function is accessible via the complex menu. It's option number 5, as you see here. Then, to get the angle of your output, input your complex number into the angle function, also accessible via the complex menu, to get the angle in radians above the horizontal. You might need to convert that to degrees above the horizontal by multiplying by 180 over pi. As a few final notes, make sure that when you're writing down your answer, you bring back the units you might have removed, such as the meters we removed from those 30 meters northwest earlier, and ensure that you're actually giving the correct format of your answer. It might actually need to be in Cartesian, and you don't need to convert out from polar. Also, I would like to thank the operators of the emulator TI-84 Calc, which allowed me to create the calculator screenshots you see on this slideshow.